When we have two brackets, x plus 2 times by x plus 3, then we know how to multiply these two brackets out. We have x times by x, that gives us x squared. We have x times by 3, gives us 3x. 2 times by x gives us 2x, and then 2 times by 3 gives us 6. And we can simplify these two terms. 3x plus 2x gives us 5x. And this is an example of a quadratic expression or quadratic function. It's got a term in x squared, which it must have to be a quadratic expression. It's got a term in x, which it might or might not have, and it's got a constant term. And there are no other possibilities. So our most general quadratic expression would be ax squared plus bx plus c. What we're going to have a look at is how we factorise expressions like this. In other words, how we go back from this kind of expression to this. Now, why might we want to do that? Well, let's just take this. X squared plus 5x plus 6, and let's say it's not just an expression, but it's an equation. And it says equals 0. What are the values of x that will make it equal to 0, that are answers to that equation? Well, one of the things we can do is to rewrite this form by this. So we can say x plus 2 times by x plus 3 equals 0. And when we have two numbers that multiply together to give 0, then one of the things that must be true is that one of them's 0, or the other one's 0, or they're both 0. So in this case, x plus 2 equals 0, or x plus 3 equals 0. And so x would be minus 2, or x would be minus 3. So being able to factorise actually helps us to solve a new kind of equation. So we're going to be having a look in this video at how you factorise this kind of function, this kind of expression, a quadratic expression. Now, I'm going to start by going back to this little piece of work again. So let's write it down. X plus 3 times by x plus 2. And again, we'll multiply out the brackets. X times by x is x squared. X times by 2 is 2x. 3 times by x is 3x. 3 times by 2 is 6. And this simplifies to x squared plus 5x plus 6. So we've gone one way. What happens if we want to go back the other way? Let's have a look where this 6 came from. Well, we know it came from 3 times by 2. Now, where did this 5 come from? Well, it came from 2 plus 3. So if we were to reverse this process, we'd be looking for two numbers that multiply together to give us 6, and two numbers that added together to give us 5. The obvious ones that go in there are 3 and 2. So if we began with this, we would be looking to break that 5x down as x squared plus 3x plus 2x plus 6. Then we could look at these two and see if there was a common factor, and there is x, leaving us with x plus 3. Then we would look at these two. Is there a common factor? And there is 2, leaving us again with x plus 3. And then we've got this common factor of x plus 3 in each of these two lumps of algebra. So we can take out that x plus 3, and we've got the other factor left, x times by x plus 3, and 2 times by x plus 3. And so we've arrived at that factorisation, those brackets that we started off with. Now, that's what we've done. And what we need to do is to be able to repeat this process of looking for numbers that multiply together to give the constant term and numbers that will add together to give the x term. So let's have a little bit of practice at that. Let's look at x squared minus 7x plus 12. So we want two numbers that will multiply together to give us 12, times together to give us 12, and will add together to give us minus 7. Minus 4 times minus 3 is 12, and minus 4 plus minus 3 gives us minus 7. So let's just write those in. Minus 4 times minus 3 gives us plus 12, and minus 4 plus minus 3 gives us minus 7. So that's given us a way of breaking down this minus 7x. X squared minus 4x minus 3x plus 12. So now we look at these two at the front, take out x as a common factor. That gives us x minus 4. And now we look at these two. Well, I want to make sure I get the same factor, x minus 4. Clearly, in these two terms, there is a factor of 3, but here I've got minus 3. So I think I'm going to have to make the factor not 3, but minus 3. So that's minus 3 times x. So that ensures when I multiply these two together, minus 3 times by x, I do get minus 3x. But now I need minus 3 times by something that's got to give me plus 12. So that will have to be minus 4. And close the bracket. Now again, I've got two lumps of algebra, and in each one there is the same factor, this common factor of x minus 4. X minus 4. So I'll take that as my common factor, x minus 4. Then I've got x minus 4 times by x, and x minus 4 times by minus 3. And that's my factorisation of that. Let's take another one. X squared minus 5x minus 14. So now, looking for two numbers to multiply together to give minus 14 and add together to give minus 5. Fairly obvious factors of 14 are 7 and 2. So can we play with 7 and 2? Well, if we made it minus 7 and plus 2, then minus 7 times by plus 2 would give us minus 14, and minus 7 plus the 2 would give us minus 5. So minus 7 and 2 look like the two numbers that we need. So let's break down this minus 5x as minus 7x plus 2x. And let's not forget the minus 14 that we had. Again, let's look at these two, the front two terms. Common factor, yes, it's x. Take that out. X minus 7. And here, a common factor of plus 2. Let's take that out, and x minus 7. 2 lumps of algebra, that one, and each one's got the same factor in, this x minus 7. So we'll take that as our common factor. So x minus 7 is multiplying x, and it's also multiplying plus 2. So again, there we've arrived at a factorisation of this. X squared minus 5x minus 14 factorises as x minus 7, x plus 2. Take x squared minus 9x plus 20. Now, from what we've got already, it might be that some of you watching this might think, well, do I need to do that every time? The answer is no. Sometimes you may be able to do these by inspection, which means looking at it and doing the working out in your head rather than on the paper. So to do it by inspection, what we might do is write down the pair of brackets to begin with. Recognise x squared means we're going to have an x and an x. Recognise 20 as being 4 times by 5, and of course 4 plus 5 would give me 9. But I want minus 9. So perhaps what I need is minus 4 and minus 5, because minus 4 times by minus 5 is going to give me plus 20, and minus 4x minus 5x is going to give me minus 9x. So I've done that one by inspection, but I could have done it in exactly the same way as I did the other two. Let's take x squared minus 9x minus 22. And again, let's try this one out by inspection. So, pair of brackets, x and x in front of each bracket. Let's have a look at minus 22. Two numbers to multiply together to give minus 22. Well, likely candidates are minus 11 and 2, or minus 2 and 11. But at the end of the day, I need minus 9x, and that kind of suggests that perhaps we've got to have the bigger of 11 and 2 as being negative and the smaller one as being positive. Let's just check. Minus 11 times plus 2 gives me minus 22, and then I have minus 11x and 2x, which gives me minus 9x. So again, we've done that one by inspection. Again, you don't have to do it by inspection. You can use the previous method. If we have quadratic expressions which don't have a unit coefficient, now this is one that has a unit coefficient because this is 1x squared. It could be 2x squared, it could be 6x squared, it could be 11x squared, it could be anything times by x squared. That would be harder to do. So let's have a look at how we might tackle some of those. So we take 3x squared plus 5x minus 2. Now I'm going to use a method that's very similar to the first method that we saw. I'm going to look for two numbers that multiply together to give, well, let's leave that unsaid for the minute. But these two numbers are going to add together to give 5. They're going to add together to give this plus 5, the x term. So that hasn't changed. We're looking for two numbers that will add together to give us the coefficient of x. What do the two numbers have to multiply together to give us? Well, they have to multiply together to give us 3 times by minus 2. So we don't just take the constant term, we multiply it by the coefficient of the x squared. And 3 times by minus 2 is minus 6. And I'll just write that here at the side, that the minus 6 came from the 3 times by the minus 2. And if you think about it, that's actually consistent with what we were doing before, because in the previous examples, this number in front of the x squared had been 1. And so 1 times by minus 2 would be the constant term. So we are looking now for two numbers to multiply together to give us minus 6 and add together to give us 5. Well, 3 times by 2, well, 3 times by 2 would give us plus 6. Minus 3 times by minus 2 would also give us plus 6, so that's not good. 6 and 1. Well, if we could have 6 times by minus 1, that would give us minus 6, and 6 add minus 1 would give us 5. So this looks like the combination that we want. So we take 3x squared plus 6x minus x minus 2. Let's have a look for a common factor here. Well, there's a 3x squared and a 6x. So there's obviously a 3 as a factor and also an x. So let's take out 3x. Leaves me x plus 2. 3x times by x gives us the 3x squared. 3x times by 2 gives us 6x. And now I want a common factor for these two terms, minus x minus 2. Well, they don't seem to share anything in common, but they've got a common factor, and it's minus 1. Minus 1 times. Minus 1 times by something has to give me minus x, so that must be x. And minus 1 times by something has to give me minus 2. Well, that's got to be plus 2. So now I've got these two lumps of algebra again, this one and this one. And each lump has the same factor in it, this common factor of x plus 2. So I'll take that one out, x plus 2. And I've got x plus 2 multiplying 3x. And x plus 2 multiplying minus 1. And so there's the factorization of the expression that we began with. Let's take another one. 2x squared plus 5x minus 7. So we're looking for two numbers that will multiply together to give us 2 times by minus 7. So they must multiply together to give us minus 14. Just write down again at the side that the minus 14 comes from minus 7 times by 2. And then these two numbers, whatever they are, have got to add together to give us the coefficient of x, plus 5. So what are these two numbers? Well, 7 and 2 seem reasonable factors of 14, and they are factors of 14 which have a difference, if you like, of 5. So they seem good options, 7 and 2, 7 and 2. But we've got to make a balance here. We need plus 5 and we need minus 14. So one of these has got to be negative, and it looks like it's going to have to be negative 2 in order that 7 plus negative 2 should give us the 5 there. So now we can write this down as 2x squared, breaking up that plus 5x as plus 7x minus 2x, and then minus 7 at the end. What have we got here as a common factor? Well, we've got an x in each term, so we can take that out, giving us 2x plus 7. And here again, what have we got for a common factor? Well, the only thing that's in common is 1, and there's a minus sign with each one, so it's minus 1 times 2x plus 7. Minus 1 times by 2x gives us minus 2x. Minus 1 times plus 7 gives us minus 7. We close the bracket. Two lumps of algebra again, this one and this one. In each one, there's this common factor of 2x plus 7. So we'll take that out, 2x plus 7, and that's multiplying x, and it's multiplying minus 1. And so we have got this factorization of the expression that we began with. Take another example, 6x squared minus 5x minus 4. Now what's different here is that this is not a prime number. We've had a 2 and we've had a 3, but this is a 6. You might have been able to do the other two by inspection, but this one is more difficult to do by inspection, and really we perhaps are going to have to depend upon the method that we've just learned. So we're looking again for two numbers that we'll multiply together to give us 6 times by minus 4. In other words, minus 24. Okay, I'll just write that down so we can see where it's come from. Minus 24 is 6 times by minus 4. And we want these two numbers, whatever they are, they've also got to add together to give us the coefficient of x. So they must add together to give us minus 5. So, two numbers that might multiply to give us 24. 8 and 3 look good options, and 8 and 3 do have a difference of 5. So they look options we can use. Now let's juggle the signs. We need to have minus 5, so that would suggest that the 8's got to be the negative one. So let's have minus 8 times by 3, that will give us minus 24, and minus 8 plus 3, that will give us minus 5. So we've got 6x squared minus 8x plus 3x, breaking down that 5x, minus 4. Common factor here. Well, the 6 and the 3 share a common factor of 3, and of course with x squared and x, common factor of x. So we can take out 3x, and that will leave us 2x plus 1. These two terms, what have we got for a common factor? Well, they clearly share a common factor of 4 and also a minus sign. So we'll take minus 4 times by, now minus 4 times by something has to give us minus 8x, so that's going to be 2x. And then minus 4 times by something has to give us minus 4, so that's got to be plus 1. Again, two lumps of algebra sharing this common factor of 2x plus 1. So we'll take that out. And then we have 2x plus 1 multiplying 3x. And 2x plus 1 multiplying minus 4. We'll take one final example of this kind. I've got 15x squared minus 3x minus 18. Now in all the others, the thing that we haven't checked at the beginning, and perhaps we should have done, is do the coefficients, the numbers that multiply the x squared, that multiply the x and the constant term, share a common factor. And in this case they do. There's a common factor of 3. And where there is a common factor, we need to take it out to begin with. So we'll take the 3 out. 3 times by something has to give us 15x squared. So 3 times by 5x squared will do that. 3 times by something has to give us minus 3x. So 3 times by minus x will do that. 3 times by something has to give us minus 18, and so minus 6 will do that. And now we're looking at factorizing this expression here in the bracket. And we're looking for two numbers that will multiply together to give us 5 times by minus 6, which is minus 30. And And again, I'll just write down where that came from. Minus 30 was 5 times by minus 6. And I'm looking for two numbers that will add together to give me, now here, the number that's multiplying the x is minus 1. So, I want two numbers to multiply together to give me minus 30 and add together to give me minus 1. Well, 5 and 6 seem like obvious choices because they've got a difference of 1 and they multiply together to give 30. So how can I juggle the signs with the 5 and the 6? Well, 5 plus 6 has to give me minus 1. It looks like the 6 is going to have to carry the minus sign. So 5 plus minus 6 does give me minus 1, and 5 times by minus 6 does give me minus 30. So I'm going to have 3 brackets 5x squared plus 5x minus 6x. So we've broken down this minus x into 5x minus 6x, and then the final term on the end, minus 6, and close the bracket. Keep the 3 outside. Let's look at the front two terms here. There's a common factor of 5x. Let's take that out. 5x, x plus 1. 5x times by x gives me the 5x squared. 5x times by 1 gives me the 5x. The common factor here is minus 6. Each of these terms shares a 6 and the minus sign. So we'll take out the factor minus 6, and then we need minus 6 times by has to give us minus 6x, so that's times by x. And minus 6 times by something has to give us minus 6, so that's minus 6 times by 1. And then I need to make sure I close the whole bracket with that big one there. Two lumps of algebra, each sharing this common factor of x plus 1. Let's take that out. 3 bracket x plus 1 times by, and the x plus 1 times 5x, and the x plus 1 also times minus 6. And so we've completed that factorization. Okay, we've looked at a series of examples, and we've developed a way of handling these that enables us to factorize these quadratics. There hasn't really been anything special about them. What I want to do now is have a look at 3 particular special cases. Let's begin with the first special case by having a look at x squared minus 9. Now, what's obviously different about this one from the previous examples is that there's no x term. It just says x squared minus 9. So let's do it in the way that we would do. We'd look for two numbers that would multiply together to give us minus 9 and add together to give us the x coefficient. But there is no x coefficient. That means the coefficient has to be 0. 0 times by x, no x's. So I've got to find two numbers that multiply together to give minus 9 and add together to give 0. Well, fairly obviously they've got to be the same size but different sign. So minus 3 and 3 fit the bill perfectly. So we have x squared minus 3x plus 3x minus 9. Look at the front two terms. There's a common factor of x, leaving me with x minus 3. Look at the back two terms. There's a common factor of 3, leaving x minus 3. And now two lumps of algebra, each sharing this common factor of x minus 3. So x minus 3 multiplies the x and multiplies the 3. Well, if we compare this with this, not only is this x squared that we get x times by x, but this 9, forgetting the minus sign for a moment, is 3 squared. 3 times by 3. So in fact, this expression could be rewritten as x squared minus 3 squared. In other words, it's the difference of 2 squares. So let's do this again, but more generally. In other words, instead of minus 9, which is minus 3 squared, let's write minus a squared. So we have x squared minus a squared. We want to factorize it, so we're looking for two numbers that multiply together to give minus a squared and add together to give 0, because there are no x's. So minus a and a fit the bill. So we're going to have x squared minus ax plus ax minus a squared. Common factor of x here, x minus a, and a common factor of a here, x minus a again. Two lumps of algebra, each one sharing this common factor of x minus a. X minus a multiplies x and multiplies a. So we now have what is in effect a standard result. We have what's called the difference of two squares and its factorization. So let's just write that down again. X squared minus a squared is always equal to x minus a, x plus a. So that if we can identify this number that appears here as a square number, we can use this factorization immediately. So what if we had something, say, like x squared minus 25? Well, we recognize 25 as being 5 squared. So immediately we can write this down as x minus 5, x plus 5. What if we had something like 2x squared minus 32? Doesn't really look like that, does it? But there is a common factor of 2. So, as we've said before, take the common factor out to begin with, leaving us with x squared minus 16. And of course, 16 is 4 squared. So this is 2x minus 4, x plus 4. Supposing we had 9x squared minus 16. What about this one? Again, look at this term here, 9x squared. It is a complete square. It's 3x times by 3x. So instead of just working with an x, why can't we just work with a 3x? And of course, that's what we are going to do. This must be 3x and 3x, and the 16 is 4 squared, so 3x minus 4, 3x plus 4. And again, this is still the difference of two squares. So that's one, the first special case, and we really do have to learn that one and remember it, because it's a very, very important factorization. Let's have a look now at another factorization, special case. Having just done the difference of two squares, looking at this quadratic expression, we've got a square at the front, x squared, and a square at the end, 5 squared. But we've got 10x in the middle. Okay, we know how to handle it, so let's not worry too much. We want two numbers that multiply together to give 25, and two numbers that add together to give us 10. The obvious choice for that is 5 and 5. 5 times by 5 is 25. 5 plus 5 is 10. So we break that middle term down, x squared plus 5x plus 5x plus 25. Look at the front two terms, a common factor of x, leaving us with x plus 5. Look at the back two terms, a common factor of plus 5, leaving us with x plus 5. Two lumps of algebra sharing a common factor of x plus 5. X plus 5 multiplies x, and x plus 5 multiplies plus 5. But these two are the same. So this is x plus 5 all squared. In other words, what we've got here, x squared plus 10x plus 25, is a complete square. X plus 5 all squared. And we call that a complete square. Take another example, x squared minus 8x plus 16. We recognise this is a square number, x squared, and this is a square number. 16 is 4 squared. And of course, minus 4 plus minus 4 would give us 8. As indeed, minus 4 times by minus 4 would give us plus 16. So immediately, recognising this as the complete square, x minus 4 all squared. One more. 25x squared minus 20x plus 4. $25x squared is a complete square. It's a square number. It's the result of multiplying 5x by itself. 4 is a square number. It's 2 times by 2. Minus 20x? Well, if I say this is a complete square, then I've got to have minus 2 in there. Minus 2 times by minus 2 would give me 4. Minus 2 times by the 5x would give me minus 10x, and I'm going to have 2 of them, minus 20x. So again, I recognise this as a complete square. You might have found that a little bit confusing and a little bit quick. That doesn't matter, because if you don't recognise it, you can still use the previous method on it. Let's just check that. 25x squared minus 20x plus 4. So if we didn't recognise this as a complete square, we would be looking for two numbers that would multiply together to give us 100. The 100 is 4 times by 25. Just write this at the side. 4 times by 25. And two numbers that would add together to give us minus 20. The obvious choices are 10 and 10. Well, minus 10 and minus 10, because we want minus 10 times by minus 10 to give plus 100, and minus 10 plus minus 10 to give us minus 20. So we take this expression, 25x squared, and we break down the minus 20x as minus 10x minus 10x, and we have the last term plus 4. We look at the front two terms for a common factor, and clearly there is 5x. Gives me 5x minus 2. Now I look for a common factor in the last two terms. There is a common factor of 2 here, because 2 times 5 gives us 10, and 2 times 2 gives us 4. But there is this minus sign. So perhaps we better take minus 2 as our common factor. which will give us minus 2 times by something has to give us minus 10x. That's going to be 5x. And minus 2 times by something has to give us plus 4, which is going to have to be minus 2. Two lumps of algebra. The common factor is 5x minus 2. 5x minus 2 is multiplying 5x, and it's also multiplying minus 2. And so we have got this again as a complete square, but not by inspection, but using our standard method. So that deals with the second special case. Let's now have a look at the third and final special case, and this is when we don't have a constant term. And we've got something like 3x squared minus 8x. What do we do with that? Well, clearly there is a common factor of x, so we must take that out to begin with. So we take out x. We've got 3x squared, so x times by 3x must give us the 3x squared. And then x times by something to give us the minus 8x, well, it's got to be minus 8. And that's all that we need to do. We've broken it down into two brackets, x times by 3x minus 8. What if, say, we had 10x squared plus 5x? Well, again, we look for a common factor. Obviously, there's an x as a common factor again, but there's more this time because there's 10 and 5, which share a common factor of 5. So we need to pull out the whole of that as 5x. 5 times by 2 will give us the 10. So that's 5x times by 2x will give us the 10x squared, plus 5x times by something to give us 5x. That must just be 1. So long as we remember to inspect the quadratic expression first and check for common factors, this particular one shouldn't cause us any difficulties.